Okay, so this is transports homework number 3. So for this homework, we are given 2 tanks, and we're gonna call these tank 1 and tank 2. And so tank 1 is at a height of H1, and tank 2 is at a height of H2, and this is going to have an area of area 1, this will have an area of area 2, and so we are given that there is a flow rate going into tank 1. It's going to be called Q1, and then we have a flow rate going from tank 1 to tank 2, and that's going to be called Q12, and then we have a flow rate exiting tank 2, and we're going to call that Q2. And then so what we know is the flow rate of Q1 is going to be given later, so we'll just put that as a question mark. And then the flow rate of 1, 2 is going to be 0.5 multiplied by the square root of H1 minus H2. And then Q2 is going to be 0.25 multiplied by the square root of H2. And then so we want to come up with the equations for our flows and basically relative to our height. So in this system, we're assuming that the flow going in is going to be equal to the flow going out. So therefore, we want to have the volumetric change in respect to t. So for our first tank, we're going to have that as area times H1 in respect to time. And that's going to be our Q1 minus Q12. And then we can simplify this by dividing the area over because the area is a constant. So therefore we're going to have H1 dt is now equal to Q1 minus Q12 all over the area of 1. And then this is going to be relatively similar when we're looking at our second tank. We're also going to have this, but this is going to be in respect to the second area and the second height and time. And then this is going to be our Q12 flow rate minus our Q2 flow rate. And then again, we can simplify this the same way by dividing the area over because again, it's a constant. So then we're going to have H2 over dt is equal to Q12 minus Q2 all over A2. And then so these are going to be the equations that I use in my Python code.